Okay, we are going to now answer ministry exam questions about pure resistance in an AC circuit. The question number 1. An electric heater operates under alternating potential difference of effective value 200 volts. So this is effective potential difference. If the resistance of the heater is 500 ohm, this is resistors R. Calculate generated heat energy if the current runs in the heater for half an hour, which is delta T. Half an hour is 30 minutes, and also 30 minutes is equal to 30 times 60, which is going to be 1,800 seconds. So we are going to calculate the energy. Equation for calculating energy: power of the heater multiplied by delta T. And because effective value of the potential difference is given, and delta E is going to be power equation for in terms of effective potential difference is VE squared divided by R is the power equation in terms of effective potential difference multiplied by delta T is going to be the energy. So V effective is 200 volts, square root of 200 volt divided by R is given as 500 multiplied by delta T, which is 1,800 seconds. Now let's multiply them all. 200 squared divided by 500 multiplied by 1,800. Result is going to be delta is going to be 144,000 joule. But answer is given in kilojoule. To get it in kilojoule, you have to divide this joule by 1,000. 144,000 divided by 1,000. So it's going to be 144 joule. So choice B is the correct answer. Question number 2. An AC generator has a maximum output EMF of 110 root 2 volt. So this is V maximum. Generator's maximum EMF is 110 root 2 volt. Find RMS current. RMS current means effective current when the generator is connected to 55 ohm resistor. So R is 55 ohm. To get the effective current, I need to know effective potential difference first. Let's first get effective potential difference, which is maximum potential difference divided by root of 2. Maximum potential difference 110 root 2 divided by root of 2. So effective potential difference is going to be 110 volt. Now I can apply the Ohm's law. Effective electric current is effective potential difference divided by resistance. So effective potential difference is calculated by 110 divided by resistance 55, which is going to be 2 ampere. So effective electric current in the circuit is 2 ampere. B is the correct answer. Question number 3. A resistor of resistance 20 ohm, so this is R, is connected across an AC source. If the energy dissipated, which is converted to heat energy in the resistor for 5 minutes, is 1.5 kilojoule. So delta T is 5 minutes, and 5 minutes is equal to 5 times 60, which is going to be 300 seconds. Energy given out by the heater, this resistor, is 1.5 kilojoule, but in calculation we don't use kilojoule, we have to get converted to joule by multiplying 1,000. 1.5 multiplied by 1,000, which is going to be 1,500 joules. So what is the effective value of the current? I am going to write energy equation which is power multiplied by delta T. A power must be written in terms of effective current to get the effective current, of course. Delta energy given out is equal to. So power of a resistor in terms of effective value is, effective current is I effective squared times R. This is the power equation multiplied by delta T. So delta E is, which is energy given out, is 1500. Effective current is the question. R is given as 20 ohm. Delta T is calculated as 300 seconds. So divide both sides by 20 times 300. Divide 20 times 300. So I effective square is going to be, so let's use the calculator, 1500 divided by 20 times 300, which is equal to 0.25. So when we get the root of both sides, effective electric current is going to be 0.5 amperes. So C is the correct answer. And question number 4. In an AC circuit, an AC circuit is made above a source and a resistor of pure resistance. If the frequency of the voltmeter increases in the circuit, the value of the pure resistors. Resistance value does not change with the frequency, because resistance of a conductor only changes by its length, by its cross-section area, by its type, which is on, and also temperature can affect the resistance. Nothing else can change the resistance of a conductor. That's why it doesn't change with the frequency. Question number 5. A resistor of resistance 35 ohm, which is R, is connected across an AC source. If the energy dissipated, converted to heat in the resistor in 2 minutes is 1.05 kilojoule. What is the effective value of the current in the resistor? I think we calculated a question similar to this one. The question number 3 is very similar to this one. Let's solve this again once. Delta T is given as 2 minutes, 2 times 60, which is going to be 120 seconds. Energy is given as 1.05 kilojoule, sorry, but kilojoule is not used in calculation. We have to convert it to joule by multiplying 1000. It's going to be 1050 joule if you multiply this by 1000. Then I'm going to use the energy equation. Energy dissipated is power of the resistor multiplied by delta T. Because effective value of the current is the question, I'm going to write the equation of the power related to the effective value, which is effective value of the current multiplied square times R multiplied by delta T. Energy is 1050. Effective current square times R is 35. Delta T is 120. So divide both sides by 35 times 120. So divide here by 35 times 120. Effective current square is going to be, let's use the calculator, 1050 divided by bracket 35 times 120, close the bracket. Answer is 0.25 again. So when we get the root of both sides, effective current is going to be 4.5 ampere. So B is the correct answer. And question number 6. The power of a bulb is 60 watts. So power is 60 watts. And its effective value of the current is 0.5 ampere. So what is the effective potential difference? Effective potential difference is question. Power, PV. So we can use this equation normal, no DC power calculation equation, but effective value is assumed to be a direct current. That's why we can use I effective and V effective multiply them, we get the power. 60 watt is the power. Effective electric current is 0.5. So effective potential difference is the question. Divide both sides by 0.5. So result is going to be 120 volt. So effective potential difference 120 volt. So these are the answer solutions of the pure inductance, pure resistance in AC circuit.